Hey, Dr. Clark back with you. Now we've got example 10.4. The question is, do students who spend more time in non-academic activity tend to have lower GPAs? So I guess the idea with this research question was, oh, some students were, they were spending more time, on different activities, which could be sports, could be work, could be, playing video games, all kinds of things. The more time you spend on non-academic activities, maybe the less time you have to do your academic work, and then maybe your GPA is lower. Maybe not, right? So that's the question. What did they do? So they got 34 undergraduate students from the University of Minnesota, and they asked them questions about how much time they spent at work, watching TV, exercise, etc., etc. And then we're going to test to see if there's an association between the number of hours per week spent on non-academic activities and their GPA. Now, let's just think about this. We've got the 34 students. That's our observational units. We asked them two questions. How much time they spent on non-academic activities? Well, that is a quantitative variable. That's a number of hours. And then we asked them what their GPA was. That's a quantitative variable. So we got two quantitative variables. Each student has a number of hours, and they have a GPA. And so we can plot those data in a scatter plot, and we'll see what we get. So the null hypothesis is that there's no association, right? Why would it have anything to do with it? Why would the number of hours students spend on non-academic activities have anything to do with their GPA? If that's true, then the beta would be 0. The true slope of the regression line would be 0. Now again, there's 34 students in our sample, but what we're interested in is this a general pattern among all students at the University of Minnesota. So there's a population of all students. We don't have the data for the entire population, so we're using these 34 students to give us insight in what would be true for the whole population. Alternatively, there could be an association. If there were an association, then the slope of the regression line wouldn't be 0, and it would be something else, and we got to figure out what that is. Okay, so we run this, we take the data we had, we plot it into a scatter plot. You can see there's a lot of noise in the data, but there is a general slight trend down that the more hours you spend in non-academic activities, the lower the GPA. It's not an incredibly strong fit, and we really shouldn't expect it to be that strong of an association because, frankly, if you said, well, I spend 42 hours a week on non-academic activities, I shouldn't be able to predict your GPA, right? It might tell me something about your GPA, but it shouldn't be able to predict it perfectly. But that doesn't mean that there's no association. So we do have a slope that isn't 0. It's not very far from 0, but it could be statistically significant. Okay, and just to kind of think about what this means, if you spent 0 hours doing non-academic activities, our predicted GPA for you would be 3.6, right? That's the y-intercept there. And for each hour that you spend doing non-academic activities, we predict your GPA would go down by 0.0059 points. So that's kind of how you interpret the y-intercept and the slope. Okay. Now, what we need to do is say, is this statistically significant? So how do you actually do that? Well, we're going to use the 3S strategy. We have our statistic, which was the observed slope. It's close to 0, but it still could be significant. We need to simulate the null distribution, calculate the slope each time, and then see if what we observed is outside the norm. So with that in mind, let's jump over to the applets. What we need first is the data. So we need the GPA data. Let's copy this. And then we're going to go to the correlation regression applet. And we are going to clear this out, paste it in, use data, and there's the data set that we just had, hours and GPA. If we click regression line, we get the exact same thing. The predicted GPA is 3.6 minus 0.0059 times the number of non-academic hours. Okay. All right, and if you wanted to know the correlation coefficient is negative 0.29, so it's negative because it's a negative relationship. It's not 0. And the R-squared value is 0.084, which they give you as a percent. Now, that's not very strong. This means that if this relationship is true, it would mean that 8.4% of the variation in GPA is explained by the number of non-academic hours. which is probably good news. That means your GPA is not simply determined by how many non-academic hours you spend. It's determined by all the work you do and whether you do it well and think and, that kind of thing. So, but you can predict 8.4% of the variation in GPA using the number of hours. So that's what we got from the data. Okay, how do we do simulation here? Well, we click the shuffle button, slide over. And what this is going to do when you click, well, we need to click slope here because we're doing inference for the slope. When you click shuffle y values, what it's going to do is it's going to take this data here and randomly spread out the y values among the x values. So we get a random scatter plot with the same x and y values, but the y values randomly thrown into the x values. And then we get a slope of that regression line, which in this case was pretty close to 0. And then that gets plotted right here on the null distribution. We shuffle them again, we get a different random slope. It's close to 0 because these are, decimals here. But we can do that a whole bunch of times. And what you see is those slopes, when you randomly do them, well, they tend to be close to 0. In fact, they tend to be close to 0 almost in a bell curve kind of look. And then what we can see is the red line, which is the true slope from our sample. Is that one of the typical ones, or is it an extreme one? Let's do, I don't know, maybe a couple hundred shuffles here. Now we see the bell curve. There we go. Okay. So we've got a nice bell curve. This is what happens by random chance in the data. And now what we want to see is how often did we get negative 0.0059? How often did that happen? Well, 39 out of 573 times, or 0.0681. Okay, so there we go. It's in the tails, but it is not far enough in the tails to be statistically significant, at least at alpha equals 0.05, right? A significance level of 0.05. So there you have it. There could be a relationship, and there probably is one, but this is not strong enough evidence. We need a bigger sample size. We had 42, which is pretty good sample size, but it is possible that you could get something as extreme or more as extreme as that by random chance. So the p-value is 0.0681. That's bigger than 0.05, and therefore we don't have strong evidence that there is a relationship. Okay, let's jump back into the slides here. So there we simulated the null distribution, and the way we did this is pretty much the same as we've been doing it all semester, right? You take your statistic, in this case the slope of the regression, and you plot that. You draw the line at the value of the statistic, negative 0.0059, and we count how many are as extreme or more extreme as that. When we did that, we ended up with not quite conclusive evidence. So there may be an association, but our evidence was not conclusive. And if there were an association, the magnitude would probably be very small because, our slope was 0.0059, right? Negative 0.0059. Then you ask the questions like, is it generalizable? Well, we had 34 students. Was it a random sample of 34 students, or did they all come from one class? Where did they come from? Were they representative? A larger sample would have been better. A representative sample would have been better. And another thing is maybe you actually have them measure how much time they spent. Don't just ask them, actually do some measuring. That can be helpful. All right. The exploration is going to see, do people with smaller hands perceive objects to be heavier? So we'll measure your hand size and then how heavy you think something is. And then maybe there's an association there, maybe there isn't. You'll get to find out, and we'll see you in the next video.